In this video, we're going to look at sum and difference formulas, and you can see that we have three of those here with the sine, cosine, and tangent. And if you look closely, you'll notice that this is going to allow us to take the sine of u either plus or minus v, and we can simplify that or expand it into sine of u cosine of v plus or minus cosine of u sine of v. And what you're going to find out once we get into an example is how we can use that to help us to find the sine, cosine, or tangent of an angle that is not on our unit circle. So if we're trying to find the exact value here, we can use the sum and difference to help us do that. So one thing I do want to point out, you'll notice this says sine plus or minus v. Well, that means that we could read this as the sine of u plus v, and that would be equal to sine of u times cosine of v plus cosine of u sine of v. If our problem was the sine of u minus v, then we would use sine of u cosine of v minus the cosine of u sine of v. Okay, and for the cosine function, I want you to realize it indicates that we have the sine of u plus or minus. Well, if our problem was the cosine of u plus v, then when we use the formula over here, we're going to use the same symbol that's on top, so we would use the minus sign. Whereas if we were using the minus sign here, then we would use the positive sign over here. So you want to be consistent. If you're using the sign on top on the left, then we must use the sign on the top on the right. All right, so let me look at an example to help us explain this a little bit further. So if we look at the first example here that we have, the cosine, and I've split this up already. This is the cosine of 120 degrees plus 45 degrees. And for example, let's say that the original problem was, what if we add 120 and 45? Well, 120 and 45 would give us 165. And if we go over here to the unit circle, we do not have a 165 degree angle. We have 150 degrees, and then we jump to 180, but we do not have a 165 degree angle. However, if we were to split that up to the cosine of 120 plus 45 degrees, you'll notice that we actually have an angle of 120 degrees and we have an angle of 45 degrees. So if we use this formula here with the cosine of u plus v is equal to the cosine of u cosine of v minus sine of u sine of v, then we can use this part of the formula to actually find the cosine of this 165 degree angle. So on this problem, we're going to look at using the 120, and it doesn't matter here, but we're going to call this u, and the 45 degree is going to be equal to v. So if we use the formula here, then that means we would have the cosine of u cosine of v, so that would certainly be the cosine of 120 degrees, the cosine of 45 degrees minus the sine of 120, and then multiplied by the sine of 45 degrees. So that's easy enough to simply substitute wherever you have a u, we're going to substitute in 120, and anywhere that we have a v, we would substitute in the 45 degrees. Now what we can do is go to our unit circle and look at where do we have a cosine of 120 degrees. Well, if we locate 120 degrees, we can find the cosine, which is the x-coordinate, so that would be equal to a negative 1/2. And then we would look for the cosine of 45 degrees. And at 45 degrees, we have a cosine, which again is the x-coordinate. So that would be the square root of 2 over 2 minus the sine of 120. That's the y-coordinate. So that would be the square root of 3 over 2. And then the sine of 45, we would locate the y-coordinate, which is the square root of 2 over 2. And then we can simply just simplify this and multiply. So we would have what? Negative square root of 2 over 4 minus the square root of 6 over 4. And we already have a common denominator, so we could write this as the negative square root of 2 minus the square root of 6, all divided by 4. And this here would be your final answer. And you may ask, why did we go through this? Well, if you're looking for the exact answer of this angle that was 165 degrees, we could split it into these two angles, 120 and 45 degrees, so that we can identify that over here on the unit circle to find the exact value for the cosine of 165 degrees. Now, granted, if you put that into the calculator, you would come up with the decimal, but here we wanted to come up with this exact answer. And that's really all that it is to using these sum and difference formulas. So I'm going to give you another example to try, and you may want to try this on your own. You can pause the video and then continue. All right, I hope you took the time to pause the video and try this on your own. The only difference with this example is we're looking for the sine, and they've already split this up for us. Instead of degrees now, we're using radians, and we have the sine of 7 pi over 6 minus, so that means over here we're going to use minus, and then we're going to use the bottom sign as well, so it's going to be minus over here. So we have to locate our 7 pi over 6, which is here, and the pi over 3, which is here. So there we're going to be using the coordinates to substitute into the formula. So if we use this formula here, we would have the sine of u, which here we have u and v. That means we would take the sine of 7 pi over 6 multiplied by the cosine of v, which would be the cosine of pi over 3. And again, make sure we use minus the cosine of 7 pi over 6 multiplied by the sine of pi over 3. And once we have the values here, we simply can look at the circle for 7 pi over 6, and we're looking for the sine of 7 pi over 6, so that's the y-coordinate, which would be a negative 1/2. And at pi over 3, we want the cosine, so that would be the x-coordinate, which would be a positive 1/2, minus the cosine of 7 pi over 6. And the cosine, once again, is the x. So that would give us a negative square root of 3 over 2. And the sine of pi over 3 would be the y-coordinate, which is the square root of 3 over 2. And once again, all we have to do is multiply this out and simplify. So we would end up with a negative 1/4 plus the two negatives make it positive, and square root of 3 times the square root of 3, well, the square roots then would cancel out, and we'd be left with 3 over 4. And of course, 1/4 plus 3/4 would leave you with 2/4, which would be equal to 1/2. And once again, notice we end up with the exact answer. And of course, here, if you would have put this in, you would have ended up with being 1/2. You could have certainly ended up with the exact answer as well. But we want to practice how we can use these sum and difference formulas. And in future videos, we're going to look at how we can actually use this to not only find exact values of your trig functions, but how to either expand or simplify your trig expressions. All right, one last video to look at, and this one here, if you notice, we have the sine of 105 degrees, and this one you actually need to determine what two angles we want to use, because once again, if we look at the unit circle over here, we don't have an angle of 105 degrees, so you're going to have to start out with this problem and find out the sine of what angle, and then we need to figure out, are we going to use plus or minus that will add up to another angle to give us 105. So what angle can we pick to either add or subtract to another angle? And we want to pick one of these angles that we have listed on the unit circle that will either add together or subtract to give us 105. Once again, I'd like you to pause the video and see if you can figure out what two angles you want to use. And you're going to realize that there's more than one choice. So if you pick something different than I do, you should still end up with the same answer. So please take a minute to try this on your own. All right, the sine of 105, what I'm going to use is I'm actually going to take the sine of 60 degrees plus 45 degrees. And again, if you pick something different, that is certainly okay, as long as they give you 105 degrees. So since I'm using plus, that means I'm using the plus sign here, so I have to use the plus sign over here. So to expand this, we would get the sine of, this is u plus v, so the sine of 60 degrees multiplied by the cosine of 45 plus the cosine of 60 degrees and the sine of 45 degrees. And once again, we have our 60-degree angle and the 45-degree angle, and I want to find the sine of 60, which means that would be the y-coordinate. So that's the square root of 3 over 2. And the cosine, which is the x-coordinate here at 45, is a positive square root of 2 over 2, plus the cosine of 60, which is the x, so that's 1/2, and the sine of 45, which is the y-coordinate, so that's a positive square root of 2 over 2. And once again, we simply multiply this. Square root of 3, square root of 2 would be the square root of 6 over 4 plus the square root of 2 over 4. And since we have a common denominator, we can simply add this to the square root of 6 plus the square root of 2 all over 4. And there we have our exact answer. So once again, that shows you how we can use the sum and difference formulas. And I didn't take time to look at the tangent, and that would be exactly the same way. The only thing you would need to be careful with is if you use the sine of u plus v, then the formula would be tangent of u plus the tangent of v, and then 1 minus the tangent of u, tangent of v on the bottom. So again, if you're going to use the sign that's on top, you're going to use the plus or minus sign that is always on top. Whereas if we had used the negative, then we would have used the negative on top, and then over here we would have used the positive sign. And keep in mind, of course, if we were using the tangent, when you go to the circle, the tangent, remember, is simply looking at your y-coordinate divided by your x-coordinate. So other than that, calculating the sum and difference would be exactly the same for the tangent function.